I'm Melinda. I'm an associate professor at the Eötvös Loránd University. I know that I'm not the only one from the university today, so please listen to my talk, one more research topic of LTAP. Today, I would like to quickly introduce you to our security analysis tools that can identify different vulnerabilities in Erlang and also in Elixir applications. Our work started quite a long time ago. Already in 2020, we had a talk at the Erlang workshop. Actually, one of my students presented our approach, that how we try to support secure coding with RefactorErl. Actually, at the same time or at the same year, the Erlang Ecosystem Foundation established the security working group for providing and creating secure coding recommendations for Erlang and later Elixir applications. Actually, that time was 5 years ago. We've used a bit different terminology, but actually we listed almost the same potential risk related to Erlang security or related to Erlang applications. Our approach, our static analysis approach to identify security issues in Erlang application is based on the RefactorErl tool. RefactorErl is a static source code analysis and transformation tool designed originally for Erlang. It has several features to support software maintenance and development. We have, for example, lots of features related to code comprehension. We provide a nice query language to ask information about the source code. We have built-in queries, and the developer can build their own queries about the source code, asking information or dependencies among source code components. From the name, you can deduce that the tool was originally designed for refactorings. So we have lots of transformations that we offer for the developers. And in the last years, we are focusing on source code checking different properties of the code. That may include some very simple properties about the structure of the code or the dependencies, like some linting features. But nowadays we are focusing, or not just nowadays, but since a few years, we are focusing on checking security properties of the software. So how this working? So we have the Erlang source code. And what we do is that we build an internal representation from the source code. Actually, that representation is a 3-layered semantic program graph. Because of the original design of refactoring, we store the original layout and the lexical layer of the code. And we build a syntax tree. This is our custom syntax tree. And then we perform lots of static analysis, static semantic analysis on the syntax tree, and store the result in our internal representation. When I'm talking about semantic analysis, you can think about very simple ones like calculating the binding structure of the variables, or storing and calculating a static call graph. But for example, we also calculate side effects of functions or the dynamic call information available or calculable from the source code. We have data flow analysis to calculate the values of certain expressions. We can also perform control flow analysis using this representation. So this is a very extensive framework, semantic analyzer framework. And we use this internal representation for the security analysis as well. We look for, in the analysis part, we look for certain patterns that may represent a potential vulnerability, a potential risk in the source code. what we do is that we look into the syntactic and semantic information available in the graph and create a set of initial candidates that might hold vulnerability. But obviously that candidate list contains lots of false positive hits. So we apply, based on the semantic information available, we apply an false positive filtering on the candidate list, and we try. It's an extensible framework. So we try to drop most of the false positive hits from the candidate list. But you have to know that this is a static analysis, so we are conservative in the sense that if we cannot decide from a candidate that whether it's vulnerable or not, then we keep it in the candidate list. And at the end, we generate a report or a list of potential vulnerabilities based on the syntactic and lexical layer of the semantic program graph. What we have in the open source version of RefactorErl that we created proof of concept implementations, we have around 20 so-called checkers, security checkers that's able to identify vulnerabilities in the source code. The results can be visualized in different ways. You can use the web interface of RefactorErl and click on the vulnerability, and then it will be highlighted in the source code, or you can use simple command line interfaces and then just have the context and the expression that's potentially vulnerable. We applied our tool on several open source projects and found lots of potential vulnerabilities. We can conclude that the majority of the issues, 2/3 of the issues related to denial of service attacks through atom exhaustion. So that's the most common vulnerability in the Erlang ecosystem. We found injection-related issues as well, like OS injection, OS command injection, or beam file, unverified beam file loading, or similar issues as well. We just to provide you an example, in the OpenID Connect Client library, we applied the security on the source of the library. We applied our security analysis. We found an issue that we reported, and it's already fixed. So OpenID is safe to use. And so that was our original work related to Erlang, and then we presented this almost 2 years ago at the CountBeam, and then lots of Elixir developers asked that, okay, you can do it for Erlang, but whether you can do it for Elixir as well. And from the static analysis point of view, if you wanted to build, we believe that usually static analysis is something that is a language semantic dependent work. So whenever you wanted to do something for a programming language, then you have to analyze the source code and build an appropriate representation and build an analyzer framework that is designed and built according to the semantics of the language. But we did not want it to do it for Elixir, since we had an Erlang analyzer framework, and and everybody knows that actually there are two different syntax, but the semantics is quite similar or the same, because the Erlang virtual machine will evaluate and run the code, either if it's written in Erlang or Elixir. So what we were thinking about, that whether we can use our representation to represent somehow the Elixir source code, and then apply our analysis on the same representation. And we are lucky because whenever you compile an Elixir application, then the Elixir compiler creates the Erlang-ish version of the Elixir code, which is the abstract code in the Erlang abstract format, which is actually a syntax tree. And we also have a syntax tree in the semantic program graph. And what we did is that we take the compiled Elixir application, ask for the read the abstract code from the compiled Beam files, and actually take that syntax tree and map that syntax tree to the RefactorErl syntax tree. So basically, we drop the lexical and syntactic analysis of RefactorErl. We build directly the syntax tree from the abstract code, and then we can apply the same semantic analysis that we designed. Since it's an Erlang syntax tree, the semantic is the same as when we build it from the source code in case of Erlang applications. So we can apply the same semantic analysis on it that are already implemented in RefactorErl. And then we tried whether it results vulnerabilities or whether the security analysis is working for Elixir applications on that representation. And yeah, that works perfectly. And doing anything, we were able to spot lots of vulnerabilities in Elixir applications as well. So we just changed the very first step, which is the intermediate source code representation generation. So we load the graph or create the graph from the Beam code. But obviously, there are some differences in the Erlang and Elixir analysis. Obviously, we had to add new checkers because we can spot. So once we have an Elixir construct and then it compiled to some Erlang library functions. For example, there are lots of string interpolations that compiles to binary to atom function call inside during the compilation, so we can immediately spot it. So we have the Erlang-ish representation that's a binary to atom, so that's potentially vulnerable. So we just apply the same security analysis on it, and we can spot it. But Elixir has its own standard library that has its own vulnerabilities. So we had to add new checkers reflecting to the Elixir standard library. There is a significant difference in the result of the Elixir and Erlang application candidate list is that in case of Erlang, we can exactly mark the expression that is vulnerable in the source code because we have the original syntax and the original code with the position information and everything. But in case of Elixir, during the compilation, we actually lose the original syntax and also the position expression range information. We have just a line information in the abstract code. We try to keep that one and annotate our syntax tree with the generated line information. And in the results, in the candidate list, we use that line. And we try to, when we generate a vulnerability list, we can point the Elixir module and the line in the line information is presented that this line contains. We don't know that exactly which construct in that line, but we can point the line in the result. And also we started and we are working on domain-specific analysis related to Elixir. We try to process and support the EF's application security, web application security best practices. and whenever it's possible, to list the vulnerabilities that we can identify in the source code, like the common stuff through Ecto, SQL injection, or some cross-site scripting attacks, and so on, so on. So we've also added checkers for that. So if you ask me that what should I do if I want to secure my Erlang or Elixir application, then I can say that there is a single tool that can do it for you, and that's safe. You can ask that I was talking so far about RefactorErl and why I'm talking about safe now, because we have a collaboration with Erlang Solutions, and we created the SAFE tool, which is stands for Security Audit for Erlang and Elixir. The SAFE is using the vulnerability detector implemented based on the RefactorErl semantic analysis framework. It can be used either as a one-time audit. So if you just wanted to list your vulnerabilities, you can ask Erlang Solutions for a one-time audit for your source code. Or even if you want, you can integrate SAFE into your CI pipeline and continuously check the security or the issues in your application. And just a final note from my side is that you've heard lots of talks from my university today, and one of them was by Gergő that was talking about formally proving the existence of atom exhaustion through the list to atom calls. And you may ask that, okay, I'm talking about tools now. One of my colleagues talked about formally proving security properties. Is there any connection between the two approaches? Yes, there is a connection that both of the approaches are provided and implemented within the Eötvös Loránd University, but SAFE does not include any formally verified property at the moment. But we will see what comes. Gergő's supervisor, Daniel Horpács, is just next to my office. So we will work on the formally proven properties as well. But you have to know that this is not an easy task. So we will see when we can reach a point when an industrial proven tool like SAFE can use formally verified approaches for security identification. Thank you for your attention.